So I don't see any students right now, but I'll start uh, after a minute. I'll record this thing for if anyone wants to listen or watch this in future. Okay, so let me start the session. So I'll just give it brief tutorial of the uh, some topics. That includes like how to use hash include, binary search, and we'll discuss some sorting algorithms, and followed by we'll discuss some MCQ questions and some numerical questions as well, like sorting, those kind of stuff. So let me get started. So hash include preprocessor directive. What is this? This is like suppose you have some file and you want to include contents of this file into your C program. So how exactly to do that? I'll come to that. So this is the thing. So let's say you have stdio.h. Okay. So okay, let me continue. So how exactly do we do that? This is like uh, this whatever is within the include file, whatever file name we give. So the format is like this. This is very similar to how we include things in stdio.h or any standard header file. What we do have is that we do hash include stdio.h, but in case of some custom header, we can use this hash include like within quotation some file name. So I'll just give an example of that. But before that, why exactly do we need that? Let's say we have some function and that function is used by multiple .c files. So one way could be like we can just copy paste everything in every .c file, but again that is not really a very good solution, and also that is if we need to change just something slightly in the in the function, then again we need to update everything every C file. So that is why we use hash include myfile.h. Also, or it can be anything. So let's say, let me just give an example here. I have a compiler, and the name of the compiler is main.c, and I'm writing printf hello world. Okay. Let's say I want to define a function, something like my func. Mm. All right, and let's say I have uh, two C files. Let's say I am creating another file here. It's let's say my file dot h. All right, so here let's say I am defining a function called void my func. I am printing printf. This is hello from my func. All right, so let's say this is the something I want. Sorry, this is something I have in some .h file. Let me compile it from here. Sorry, I have to. Just sorry, I just forgot to include the thing actually. So let's say this is the file that I want to include. Uh, my my file dot image. Okay. So let me just run the program. So what is happening is that whenever this before compilation itself, it will check is there a myfile.h in the this folder. The answer is yes. So what the compiler will do, it will just copy and this will replace this thing with this. All right. So see now my func exists and it will give some it will give the desired output. So let's say we have another C file. Let's say instead of main.c, I have main2.c. We have the same thing. Let me just copy paste and let me just run. Okay, sorry. So this compiler is assumes that it should have main.c as the file name, so we cannot show it here. But the thing is that if you want some other program, some other header file which is defined by your own to use within your program, the syntax is that you have to use double quotation. Within that, you can give the file name, and in this place, whatever the contents of the myfile.h, your header file, it will get copied here. So this will happen before even compilation start. Okay, so this is the main thing. Why do we use this? So for example, here just like I have shown, it is like hashing to myfile.h, and suppose I have this thing in my myfile.h. So basically here, uh, instead of this line, the compiler will replace this part with this. So you cannot see this, but like this will happen implicitly, right? So this is how we use myfile.h. And one thing to note here is that see there are differences in syntax. So for example, hash include stdio.h. So this thing, this is used to if you give this bracket, this uses this searches stdio.h within the system file within the like C directory. But if you use double quotation, it will search within your current folder. It will search within your current folder, but if it is unable to find, then it will search the system folder. So basically, let's say if I just give it like this, I have a program like this, and let's say printing hello, printf hello, and let's say instead of stdio.h, I can also do it like this. That is also fine. But generally, we use brackets only. Okay, so see, if even with double quotation, this program is running successfully because see, I don't have stdio.h in my folder, but it doesn't matter. It will search the system folder as well next. Okay, so let's say uh, what else we can do. We can also use like hash include is done. Then about hash define. So how to define hash define. So let's say I have a sample program here. I have some variables called pi and some variable called max, things like that. So let's say I have defined hash defined pi 3.14159. So what the compiler will do, it will replace all the like pi here with 3.14159. Similarly, everything else actually it will replace with. Let me just run this program. Let me use another compiler. Oh, so okay. So basically, what is happening here is that area is pi into r. So pi it will automatically replace this with this value 3.14159. Similarly, for MSG, it will replace automatically with hello world like this. So why exactly to use that? it actually first thing is that you can see all these variables here only. Okay. So if you want to change one thing, max maybe you want to change 100, you don't need to go below. This is one benefit, but main benefit is that, like, see, if you are storing a variable, it requires a memory to store. But here it will directly replace everything before compilation. Okay, so it will be like the compilation time is fine, but runtime will be faster with this method if you use hash define. But the major drawback is that you cannot change the variable. So max 100, okay. Let's say within the main function or within some other function, you want to change the value of max, you cannot really do that with hash define. Hash define, whatever you are define, it is fixed within the program. It will, even before the compilation, it will replace everything. Okay. So this is how to use hash define. It is generally used to define constants and constant and things which will not change throughout the program. Like anywhere in the program will not change. All right. Okay. Then let me go to the next slide. Okay. So we can also define some functions with hash define. So let's say, let me also copy this program. Sorry. So basically, what I'm saying is that uh, so basically I have defined a hash define square. So I am saying that I am defining a rule that if you see anywhere square and you have some argument x, convert that to within bracket x into within bracket x like this. So basically what will happen, suppose I have given let's say square of 4. Okay. Printf, let's forget all this right now. Printf square 4 equal to sorry, I have to give a percentage d here. See, if we give square 4, what it is doing is that it is replacing this with 4 into 4 like this. Sorry, 4 into 4. So obviously the answer is fine. But uh, why exactly do we need to give these brackets within everything? The issue is that, let's say I want to give something like this. So let's say instead of this, I am defining another variable, another hash define. Let's say hash define square of x, and let's say simply I have x into x. Okay. Uh, so square of 4 will be fine, but let me give square of 4 plus 3 maybe 4 plus 3. So ideally what should happen? 4 plus 3 is 7. 7 square is 49, right? But you see, the output is, sorry, we have to, yes. So it should be 5, like 49, right? But what is happening here? It is showing 19. It is showing 19. So why exactly is that? So see, what we have run? Square of 4 plus 3. So square means it is considering x is 4 plus 3. So what it is doing? It is doing 4 plus 3 into 4 plus 3. So it is replacing it like that. But the thing is that here 3 into 4 will be applied first, right? Because this is like multiplication has higher priority. So it will be like 3 into 4 plus 4 plus 3. So it will be 19, not 49. So this is the thing you need to consider when writing the programs, when like answering the MCQs, that if there is no brackets here, then it will be replaced as it is, and that may have some unintended consequences. All right. So same for like other functions as well. Like see, in every cases to avoid this kind of situation. So let's say I gave a bracket here. Assume I have a bracket here. Okay. So what will happen in this case? In this case, like there will be a bracket within 4 plus 3. There will be a bracket within this 4 plus 3. So the answer will be again 49. Right? Yeah. In this case, the answer is 49. Sorry, this will be square of 4 plus 3. So same for like you can define a square instead of square, you can define cube or maximum, something like that. So this is how to define this. Okay, so what are the advantages? This is quite fast because it is just replacing. See, if you use function call, what does it do? It transfer the control from the main function to the function that you are calling. So there are like some overhead for the OS. But if you just a minute. So if you use macro like with hash define, it is quite faster because we don't need to do any function call or anything. Then it can, another thing is that let's say you have something called square. Okay, you are defining some square like let's say uh, like like if you define a function like let's say float square. All right, so something like this. So again, you have to give some argument like float A, float B. Okay, if you cannot change that, like you have to again define multiple functions if you want something different. Like if you want float in float, it is a different thing that it can like it can be converted to float, but ideally like for every like data type, you have to define a separate function because you cannot like if you have int, you cannot like use this function for float, right? But with a macro, that is not an issue because it will replace everything in then and there only. So here it doesn't matter if you give it int, if you give it like float, it will work. Anything. Then next thing is that yeah, so obviously speed is better, like speed is improved compared to calling a function. Another problem is that it has side effect if it has plus plus or minus minus, something like that. I'll come to that just in a bit. Uh, so what exactly is a problem? So let's say I have something like this. Like I wanted to show why exactly having a plus plus or minus minus is a problem. Uh, so let me say that I have defined a square like this only. So note that I have that brackets within both like both x. So the precedence issue like multiplication coming before addition will not occur. But there is another problem. Sorry. So like what do you think the output here will be? Output here, output of A, like if we just print A here after the like after this thing, uh, let's say result is equal to percentage D and A is equal to percentage D. And let me write result and A. So what do you think it will be? What will be the value of A? Let me compile. So the value of A. So the thing is that what do we assume that like A plus plus, right? So we assume that here we are calling a function and it will adopt the A like square. It will return square of 5, right? So it will be like 25. and it will be 6, right? After after this statement is done, it will be incremented and it will be 6. But we saw the output is 30 and A7. So why is that? Uh, it is because, see, int result is equal to, what did it do? Square of A plus plus, right? So what does it mean? It means A plus plus into A plus plus. So see, there are, if anything here, anything inside square, it is considered as a x. So if an A plus plus here is also being executed twice. All right. So at first here it is like 5, but here it is 6. So 5, yeah, 5 into 6. So it is like 30. And here, like here it is value of the, this thing is 5, incremented, what, 6. Here it is 6, important incremental 7. So here if you print the value of A, it will be 7, not 6. So this thing you need to worry about while defining some function with hash define. So it has some like unintended consequences when you use plus plus or minus minus, things like that. Because if you're using those variable multiple times, like plus plus or minus minus will get in, executed multiple times. All right. So this is another thing. All right. So then I'll just give some pitfalls. So basically, I mostly covered it just before only. So one thing is that you should always keep like use bracket to within each variable, and whole expression as well. You should apply a bracket, and also yeah, and also you need to worry about like if it is like you're considering if you will pass plus plus or minus minus in somewhere within your variable, then using macro is not really a good idea. Like it will get complicated. Okay, then I will come to starting with an array. So basically, let's say you have an array of maybe 100 elements and you want to search a value within the array. So basically, there are multiple ways of doing that, but there are mainly two ways. One is called linear search, another is called binary search. So let's come to the linear search first. What is this? This is nothing but actually let's say I have this element. I have like 5, 3, 2, 9, 8, 17, 6 like this. And let's say I want to find if there is 17 in the array. How do I do? I just go through each element one by one. Is it equal to 17? Is it equal to 17? Here I'll say yes, it is equal to 17. I'll say that yeah, I found the element, and then done. And if the element doesn't exist, we'll go till the end. We say that we have not found the element. We checked all the elements here. So the answer is no. So basically in linear search, so it doesn't matter actually. So let's say I have 2, 3, 5, 7, 8, 9, 17. So it is like uh, lowest first, then highest later. All right. So if I have, if I am checking all the elements one by one, it doesn't matter. Like even if it is unsorted, I can get a solution. Even if it is like arranged, then also I can get a solution. Right. So what is linear search basically? It is just like let's say it will suppose I want to find 8 in the array here in the array. So what it will do, it will just check with the first element. It is not true, not equal to 8. Second element, third element, like that until it found this. So this is like very basic. And what is the best case solution? When we will get the quickest result? We'll get the quickest result when, let's say I want to search 5 only. All right. And the 5 is at the beginning of the element, beginning of the array. So even if the array is like 1,000 elements, if it is like 1 lakh elements, it doesn't matter. I will get the answer in the first step itself. So that is why best case is O of one. So like it doesn't matter how many elements are in the first step. Like if it is like the first element, then the like time taken to give the answer is constant. Like it is not dependent upon the number of size, the number of elements in the array. But what is the average case? Average case is sorry. What is the worst case? Worst case is like let's say I'm trying to find out six, and what do you have to do? I have to check everything, and only at the last point I'm getting a answer that yes, it exists. Or even if it doesn't exist, then also you have to search everything. So for a large array, let's say 1 lakh elements, it will be very much slower. So that is the worst case. And what is the average case? Average case is like let's say I'm trying to find out 9 or 8, it is somewhere in middle of the array. So that is called average case. So this is between like it will not be constant, but it is like it will take around. It is also dependent upon the number of elements. It will be half of the number of elements. That is average case. Okay, so there is some implementation details. One thing is that obviously you can use a for loop and iterate through all the elements and check if it is equal to the element or not. But in this example, I have used a while. Why is that? We will be using while loop in a bit for binary search to like uh, to form an equivalence with that. I have used while loop. So basically, what we are doing here is that initially I'm saying that position is 0. So we are starting from the first element, and we will check till it is last position. And we'll also see we, like if area of position is not equal to key. So if it is equal to key, then that means we already got the element. So no need to check again. So this if this is successful, if it is equal to key, then we'll just return that yeah, we found the element at position maybe 4. But if it is not equal to, then what will we do? We'll just do plus means we'll next in the next step we'll check the next element and so on. And at the end, if we do not find the element, then what will happen? It will be like POS, the value in POS will be equal to its size, right? So initially, let's say 0, like we have 4 elements, 0, 1, 2, 3, we did not find anything. So at this point, a POS will become 4, and that is the indication that we have not found the element. So then in that case, we'll return -1. So -1 means in this case that we are unable to find the element. So let me just, okay, I will not execute the program. Let me continue. So then what is binary search? So one very important step in binary search is that uh, the array need to be sorted. Sorted in the sense it should be like increasing to decreasing. Sorry, it will be in ascending order. So like lowest value should be at the beginning, and highest value should be at the end of the array. And also there is another as well, like it can be descending as well, but for that you have to change the like binary search algorithm accordingly. So what is the intuition? Intuition here is that let's say let me just draw that. So intuition here is that let's say I have some array which is like let's say here I have 3, here we have 5, 9, 10, 11, 12. So instead of blindly searching through everything, the intuition here is that I'll check at the middle position. So what is the middle position here? Let's say I'm trying to search 12. Okay, I'm trying to search 12. And I'll check at the mid position here. Mid position is 9. So is it 12? The answer is no. So now I know that here this position is not 12, and everything on the left side it is less than 9, like less than 12. So obviously there will be no 12 in this side. So now I can say I will search within this only and see if there is 12. Okay. So what is the mid position here? Middle again is 11. So I know that anything on the left side, it will be less than 12 because here only it is less than 12. So anything left is obviously lesser. So again, we'll not search that. I'll say that this is also less than. So our only option is that this one. We'll also again check, is it equal to 12? The answer is yes. So we'll say that we found the element, the index is this. So see, if we check everything one by one, it would have been taken 1, 2, 3, 4, 5, 6 steps, but here like 1, 2, 3, 3 steps only. So like this. So the primary condition of this is it has to be sorted array, and at every step we take the midpoint and we see if it is greater than our the thing we are trying to search, or if it is less than. So if it is less than, then like if the key that you want to search is greater, then we search in the right. If it is the key is lesser, then we search in the left. And obviously, if the key is equal to the position, then we just return then and there because we found the element. So this is some example. So we have here we have like let's say I want to search 2 here. So we'll try at the mid position. Here it is 5. So at this point, so initially we started that we are starting from 0 to 5. And what is the mid position? Mid position is 2. So here we saw that no, actually we wanted 2, but it is 5. So our value will be at the left side, right? So here we saw that within this 2, then we check here 2 and we found the element, then that means it is done. So yeah, this is same thing only. Then let me go here. Let me go to the implementation part. So basically, let's say I have a binary search as a function name, and I want to return an element, the index of the array where we have found the element. And if there is no such index, like if the element does not exist, then we'll return -1. Okay. So what we are doing, we are saying that initially we are starting from -1. So basically, why -1 here? Because we are comparing left and right. Left and right, we are adding +1, and first index of an array is 0. So because we are adding +1 here, I'm giving -1 here to make it like a 0th index. So basically, I'm saying that I am adding. So here, what we are saying is that I'll come to this part just in a bit. So what we are saying here is that we have some left index, we have some right index. I am dividing that by 2, and that is our midpoint. If it is lesser than or equal to key, then it is like L is our current position, and if it is not if it is like less, if our current element is less than or equal to key, then that means midpoint is our current left side. So basically what we are saying here is that see here I'm saying that if it doesn't work, then if it is like greater, if the value, if the key is greater, then means right is the same only, we have to check till the end, but in the left side we can take from 3. And if suppose it is lesser, then left side will be the same, but in the right side we can take it as like 2. Like we have to check till this one, like this. Then I'll come to the, okay, this is fine. Just some examples. So one thing is that what is the time complexity of binary search? Uh, so no, notice one thing, like every time we are dividing the array by half, like I am taking the midpoint, and if it is greater, I'm going to the right or to the left. So every time it is getting divided. Like initially, let's say I have 1 lakh array size of like 128. So in the first step, we will check the mid position. We will say that it will not exist in left side of the array. So we'll check the right side of the array, and right side of the array will have maybe 64 elements. In the next step, again, we'll discard 32 elements in either side, and we'll work with 16 only, then 8, like this. So every time it is getting like reduced by half. So the current complexity is log base 2 of n. So let's say I have like 120 elements. So like the term, like it is proportional to the log base 2 of the number of elements. Okay. So which one is faster? Obviously, a binary search will be faster because see in linear search, we have to go through all the elements in the array. So if the array size is quite large, then it will be very difficult. But if it is like in case of like binary search, we can just divide and conquer, like divide a array and go through uh, the part of the array. So the time taken will be very lesser comparatively. Okay, so after the like binary search, let me come to the uh, sorting part. So here I have told to the binary search, you need to have the array in the sorted position. But the thing is that how exactly to sort them? Like let's say I have some array 2, 3, 7, 6, 1, 9. Obviously they're not sorted. So how to make it sorted? So sorted can be two way. One can be like 1, 2, 3, 4, 5, which is like increasing order, which we call ascending, and it can be like 5, 4, 3, 2, 1, which we call descending. Right. So this can have many like real life application. Obviously, like let's say you want to arrange the array by, if you are suppose maintaining a database, so you may want to arrange the database as per the student roll number or things like that. So there are three types of algorithms. Okay, types of algorithms that we'll cover today. There are actually multiple types of algorithm for sorting. So basically, we will at first talk about selection sort. So what does selection sort do? And there are basically three main steps. First is that scan the unsorted suffix x into xk, comma, size of array -1. So basically what we are saying is that uh, suppose uh, I have an array, I will check uh, that minimum value within that array. Then I will change position of current position with the minimum value that we found, and then we will like increase the size of array. So basically, I'll just try to show it with an example. So basically, let me just go through a visualization. Let me just describe this one only for a just for example, then I'll come to the full visualization. So let's say we have some array at this position, and we have three values already sorted. All right. And what will you do in this step? Will this part is sorted and this part is unsorted, right? So what will you do? We'll check what is the minimum value here, 31, right? So 31, I will stop with this position, and 50, I will keep it go to 50 will go to this position. So after this part will be sorted, and things like this will continue. So let me just give it to an visualization tool. Uh, we are covering selection shot here, selection shot, and just a minute. Assume that I have selection sort and I have something like this. Let me just copy paste the values here, minus 10, 10. Let me just again randomize this as well. 50, 32, 72. 10, 20, minus 10, 31. Let's assume that I have this array. Okay. Let's say there is 0. Okay. So let's assume that I have array like this. All right. So what will this algorithm do? This will at first check what is the lowest value, 0, right? So it will iterate through all the elements in the array first. It will check what is the lowest, 0. So it will bring the 0 here and 35 there. So let me just begin the animation here. So it will checking all the array. So let me just go slowly. So basically it is checking what is the first element, 35. All right, 35 is the lowest so far. Now it checks 32. 32 is lower than 35, so current lowest is 32. All right, 49 it checked, and 49 is still it is not lowest. Okay, so it will go to the 10. 10 is lower than 32, so it will say that 10 is now the lowest. All right, 20, 0, and 31. So what is happening here? Uh, here it made one iteration through all the elements. It found that 0 is the lowest element. Then what it will do, it will change the position. It will bring the 0 here and bring the 35 here, like one stop operation. So yeah, this is the iteration. So at this point, what do you have? What do you have? You have the first element, which is the lowest. Rest of the elements, you it is like it is unsorted, but first element till now it is sorted. All right. In the next step, it will check again the lowest value within this remaining thing. So what is the lowest value here? 10 is the lowest value. So it will bring the 10 to the beginning here. Yep. It bring the 10 here. Then in the next step, it will bring the 20 here and 49 there. Yep. Now 32 and here we have 31. So lowest is 31. So 31 will come here and 32 will go there. Yeah. Again, 32 will come here. 35 and 49, these positions are quite the same. So This is the basically the sorting algorithm. So at each position, it is taking the lowest value from the like initially everything was unsorted, right? So initially it will search for the lowest value in the entire array. It will find the lowest value and it will replace. It will put the lowest value in the first position and exchange the whatever was here to that position. Then in the remaining array, it will again search. It will again replace, again search in the remaining. So at every position, and at the beginning, you have partially sorted array, right? So this is that's basically selection sort. So basically, selection why? Because at every step we are selecting which element is the lowest, and we are putting that value, putting that element in the correct position. So then if we go, firstly, I am uh, like selecting the value of lowest position, which is 0, and then I'm replacing. So this is how it is called selection. So I will come to the code. Just uh, yeah. So this is just an intuition of this thing. I have already shown the visualization. So how to code this? Basically, we have to run two loops. One is we have to find the like see here here at first we have to go through all the elements and we have to check what is the minimum. So that will take one loop, okay? And outside that, we have to repeat it for all the positions, right? So that is another loop. So there will be two loop within each other, okay? So this is like this. So let's say k is equal to 0, k less than size minus 1, k plus plus. So we are thinking of the index here, that what will be the like I want to print, I want to find the lowest value, k equal to 0 means lowest value in the array, and put the value in first element. Then when k is equal to 1, I want to find the second lowest value in the array. That means lowest value in the unsorted array, like except the first array of 0, like this. So this will continue, and at every step, like we'll just like find the element whichever has the like lowest value. We'll do a swap operation, exchange operation, and this is how we can run the like the section sort algorithm. So again, like if you go through step by step here, let's say we have k equal to 0. So uh, k equal to 0 means like I want to find that uh, I want to find a value to store in the first index. So what does it mean? First index here we have to be the lowest value. What is the lowest value here? 17. So we have to exchange that. So see here, 17 is here, 3 is here. Now I have to consider what is the lowest value here. So in this part, lowest value is minus 5. So minus 5 will come here, 12 will come here. Then I have to put a value here at this position. And among these four elements, the lowest value is 3. So 3 will come here, 12 will go there, exchange. Okay. Then 6 is actually the lowest value here. So it will stay as it is. Then 12 is actually the lowest value here. So it will stay as it is. And at the end, obviously, like it will only the largest value will remain at the end because everything else is sorted. So this is how we do selection sort. So what is the time complexity? The time complexity is order of n square because see, we have two loops. Here we are running this loop for n times, which is the number of size of array. Here also it is like n times, which is proportional to the size of the loop. So n, and within the loop, we have another n. So it is like nested loop, each of size n. So n into n is n square. That is the complexity. And how much space do we need for sorting all this? We don't need any extra place except for a temporary variable, right? So it is like space is like even if it is like an array with 1 lakh elements, and if it is array with 1,000 elements, the space requirement is the same one. We don't need extra space for like performing the sorting. Okay, so selection sort is one algorithm. There is another algorithm called insertion sort. So what is this? In insertion sort, let me show you with an example. Let me, we can visualize this. So basically, sorry, let me pause this. What we are doing here is that initially I'm saying that I will sort this part only, 50 this part. So obviously, first element, let's say the thing is that I'm saying that initially I'll assume I only have this element 50. I'll forget this element, and I'll see that is this sorted. Obviously, like only one element is there. There is no question of like uh, being unsorted. If you are the only person there, you have the highest roll number, highest marks, lowest roll number, lowest everything. So this position is fine. And then I'll come to here, 30 and 50. So I'll say, is it sorted? The answer is no. So what I will do, I will uh, put uh, 50 here, sorry, 37 here, 50 here. All right. So let me just show it. So see, we just exchanged it. Then next step is that 45. So 45 is actually less than. So initial, what should happen for like ascending sort? It should happen that like it should be greater, greater, greater. Like it should be the lowest one, and this should be the greater, like highest one, right? So whenever I see that this element is lower than the previous element, so 45 is greater than 50. So what will I do? We'll check. We'll go here. At which position I can insert the 45. So 45 I can insert within 50 and 37, right? It is middle position of the like 45 is in the middle of 37 and 50. So we can insert it here. So see, yep. Now again, like these three elements are sorted right now. Then I'm coming to the next element. So where to insert 34? 34 we cannot insert here, here, here. 34 should be here. All right. So what do we have to do? We have to check. We have to shift this by one element, this by another one element, this by one element, and then we can insert it here. So see, it came here, it came here, it came here, and in Z position we have included this. Similarly, for 43, we have to shift this to this, and then we can just insert the 43 there. Okay. 49, we just have to shift it once there. Similarly, for 20, we have to place a 20 even before 34. So basically, the process is that we just check on we keep going left. We check that if is it greater than this element. If yes, then we just shift. So let's say I have shifted once, then I am checking is it still greater? Yes, shifting like this. So till we find that until we find a position where it is actually lesser, or otherwise like we go to the tail end and then we similarly this will also come to the beginning only. 28 it will shift everything till here and it will get placed here. So this is called insertion sort. So basically how to remember this, uh, insertion sort is basically you are picking an element and you are inserting it to a correct position. So initially, let's say initially this was the array, 50 was in the correct position is fine. Then you took the 37, you inserted it to a correct position. 45 again you inserted it to like current position. So every time you are getting a partially shorted array here and unshorted array here. Okay? So this is what we call insertion short. And what is our time complexity here? Time complexity here also it is order of n square because we have to run two loops. Here one loop to like to select an element that here. So here we have an element we have to run a loop to decide I have to uh, sorry, one loop is there to like let's say I have 8 here. So there will be one loop to iterate through all the previous element and move it to a right position. So this is one loop. But outside that there will be another loop. So basically that will iterate through all the element and like insert each of them to the correct position. So again, there is a loop inside the loop. So that is n into n. So n square time complexity. Okay, so finally, there is another short called bubble short. So bubble short is very simple to implement. So basically, what do we do here is that we'll run a loop and we'll check, like we'll go through all the elements one by one and we'll like exchange if they are so like say, let's say 40 and 6. All right. So 40 is greater than 6. So we'll exchange it here. 6 will come here, 40 will come here. Then again, we'll compare 1 and 40. So 40 is greater than 1. So 40 will come here, 1 will come here like this. So let me just run the visualization. So see, we are comparing 6 and 40. It got exchanged. Now we'll compare 40 and 1. It will also get exchanged. 9 and 40, it will also get exchanged. Same. So this will continue till the end, till here. Okay. So there is one iteration, and after one iteration of going through this array and exchanging the position whenever there is it is greater. So what is happening? We saw that largest element is at the end, right? So if it is like 40, so if it is largest, it will get exchanged with everything else and it will go to the end. So in the uh, next iteration, what will happen? 1 will come here, 6 will come here. These are getters not exchanging again. Sorry, got to quickly. This is getters not exchanging 10, 34 and 4. So this is greater. So these will get exchanged. So note that it will only get exchanged these two only. Okay, in bubble short, it gets exchanged with the within these two. It will not check. It will not go through these earlier positions to like place the 4. It will just exchange within itself like this. This is again higher. It will go, and here it is like 34. So see, at first iteration, I got the highest element at the end. In the second iteration, I got second highest element at the end. Like this, it will continue. It will again check the thing within this. Here it will get exchanged. 33 will come here. Okay, like this. So at the end, so at each position, I am getting the highest value within the within the array. So after that, like it is finished. So this is what we call bubble short because we are just going through, like we are just exchanging. We are considering whichever value is there in the side, and then we are comparing with it. That's it. All right. So this is bubble short, and then let me go to the MCQs. Okay. You don't really need to worry about that. This is the basic summary of this. So we have selection short. So in all three algorithms, the worst case is order of n square. So in all the cases, we use nested for loop. So In the worst case, it will run through through all the elements, uh, like in into n times. So this is for all three algorithms. There are some other efficient algorithms like merge sort, uh, which can do better, which will come in the later weeks. So in case of selection sort, we don't have any mechanism to terminate it early. All right. So selection sort is that it will run in order of n square even in the best case. So there is no best or worst case here. It is like everything is same only. Okay. But for insertion sort, or let me say let's say bubble sort. Okay. So let me say in bubble sort here in the algorithm, what happened? Let's say I am going through this. So at this point, you see 32, and at this point, all right. So at this point, you see the array is already kind of sorted. Okay. So what we can do, okay, now we have the array sorted. All right. So what will happen if we run a bubble show? We can do one thing. We can say that we'll iterate through the unsorted part. This part is unsorted. And if there is no exchange occurring, that means this part is also sorted. So you can terminate it here. So let's say I already have an sorted array at this point. Okay. Forget all this. Like assume this is the initial array. I have not sorted anything, and I run the bubble sort. So what will happen? I'll iterate through all the elements, and there will be no exchange. If there is no exchange, we can assume that this array is already sorted, and we don't have to run another loop again. So in best case, when the array is already sorted, here we can just iterate through all the elements once only. That is it. We don't need to like run it again and again. That is the best case scenario. And for insertion sort also, it is the best case. In case of best case scenario, it is like order of n. But for a selection sort, it is like order of n square because there is no mechanism to stop early stop the like sorting. Okay, so I have given the link to visualize the algorithms, and this is very helpful tool to like get an idea how exactly this sorting works. Okay, so then I'll move on to the questions. What is the best case complexity for linear search? And what is the worst case complexity of selection sort? Okay, so the answer here is A. So basically, in case of linear search, if the first element itself is correct, uh, like the value that we are trying to find, then we don't need to search through the entire array. So it is independent upon the number of elements in the array. It is constant. So it is O of one, and then what is the worst case complexity of selection sort? Just as I have told earlier, it will run through a like nested for loop, like one inside another. So it is like order of n square. Question two, which of the following are correct? Binary search is applied when elements are sorted. Uh, Binary search can be applied when elements are in random order, and linear search can be applied when elements are in random order, and binary search can be categorized into divide and conquer rule. So the answer to this question is that a binary search can be applied when elements are like all three are right actually because see binary search can be applied only when elements are sorted. So we can divide, we can like take the intuition that if it is greater than the middle element, then we have to search right. If it is lesser, then we have to search left. So it has to be sorted. Linear search, we iterate through all the elements, so it doesn't matter if it is sorted, if it is random, it will give an answer. And a binary search can be categorized into divide and conquer rules. So what is divide and conquer here? It is like in the array, we are dividing the array and we are trying to solve the like let's say the divided array. So this is like we are dividing the array and we are trying to find a solution within the divisions. So that is what is called divide and conquer. So in this case, all the answers are correct. So answer is 1, 2, and 3. Second, a third question is that what is the recurrence relation for linear search recursive algorithm? And the answer is that here. So in linear search, what we have to do? Let's say we had n elements and we found a element and here we did not find any answer. Like we found that that uh, that is not the element that we're looking. So what will happen? We have some cost for that for comparison, and we also have to check the n minus one element. So we are only able to there are n elements. We are able to eliminate one element, and now we have n minus one element left, which we also have to consider. So the reconciliation is t of n minus one plus c. Then we have an array, and what will be the mid values uh, in the first and second iteration? So let's say this has 1, 2, 3, 4, 5, 6, 7, 8. 8 elements are there. So see, initially what do? We check the left and right divided by 2. So left here is 0, index wise, left is 0, and right here is 7. So 0 plus 7 is 7, 7 by 2 is 3. 0, 1, 2, 3. So initial value will be 89. So after that, what will be the value? So after 89, and we know that here we have to search within this only. So this is like 0, this is like 2, 0 plus 2 is 2, divided by 2 is 1. So array of 40, like array of 145. So second key that we chose here is 45. So the correct answer is B, 45. Then consider an array of elements. We have 7 elements. What will be the resultant array after third pass of insertion sort? So insertion sort is where we insert each of the element to the correct position. So at the first iteration, what will happen? At the first iteration, so the answer is 4, 7, 10. So basically, what is happening at the first iteration? Let me just write it here. But at the first iteration, what will happen is that we have it will remain the same because first element is always sorted. There is nothing left to sort. 10, 4, 7, 23, 67, 12, 5. In the second, what will happen? We'll choose this 4. 4 is less than 10, so 4 and 10 will get this 7, 23, 67, 12, 5. In the third step, first step is 4, 7 is greater than 10, So we have to find a position for 7. So 10 will get shifted to the right side, and uh, then 10 got shifted to right side, and then we have to check if it is uh, greater than 4. The answer is yes, so you can write it here only. Then as usual 23, 67, 12, 5. Okay. So answer is this only. So 4, 7, 10, 23, 67, 12. So like if you get a question like this, the easiest way is that for insertion sort, you can just sort the first 3 elements. So I told after third bus. So you just have to sort the first 3 elements and remaining will remain unchanged. Okay, this is for insertion sort. Okay, then which of the code snippet performs unordered linear search iteratively? So like unordered linear search means it will find it will go through all the elements one by one, and it will like return an index where it is correct answer. So basically, let me go through the solutions one by one. So we have some index, okay, and we have array of. So we are iterating through all the elements, and we are saying if array of I is equal to data. So if it is equal, then index is equal to 1. So I am saying this is the index, and if we have found the element, then we are breaking out the loop, and we are returning the index. Okay, so this is one thing. And if suppose this is not true, in that case, like index, we have not put any value here. So like index will not be like some element of the array. So then this seems to be correct, but let's also check the other options. So here what I am doing, I am returning index, but if I have found the element, I'm not changing the index. Also, I'm not incrementing the index in my. So basically, index is remaining like undefined here on. Like anything happens within the loop, it is not changing the index. So this is not really correct. This will give a wrong answer. And on this one, uh, we are again iterating through all the loop, like all the elements in the array. If array of I is equal to data, then I'm saying index is equal to y, and then I'm saying continue. So what will happen here that if and when we found the element, it will like continue generating, like continue like iterating through like the array. So the most correct option is here. Most correct option is like option A. Question 7, which of the following input will give worst time complexity for selection short? And if you remember, for selection short, the theory is for time complexity. It is like there is no mechanism to stop, right? So doesn't matter what is the status of the array, it will take mm, like in all the cases, it is like n square only. So like 1, 2, 3, like it is like in all the cases the answer are the same. Like doesn't matter, it will take the same time. Okay, and then question 8. Consider the array. We have some array here. Apply the insertion sort to sort the array. So insertion sort, if you remember, what we do is that we go through all the element one by one, and if it is not in the correct position, we simply. So assume that every element we want to like shift, it will take uh, it will take 25 rupees. Let's say. So how will perform that? Let me describe that one. So let's say this one is the array. This one is the array. So first step, what we'll have to do, 5, 4, 9, 3. So this is fine. Second step is 4, 5. So we have to exchange this, right? 4, 5, 9, 1, 3. So we have already 25. And then third step, we have 9 we have to place in the correct position. So it is fine actually. Like 9 is in the correct position. Like initially I am checking this part only. Here I am checking these two only. Third I am checking 4, 5, 9. So it is in the highest position compared to the previous element. So it is fine. No cost here. Fourth element 4, 5, 9, 1, 3. So in this case, what will happen? We want to put the correct position. So 1 will come here. So this is another shorting that happens. So this 25 rupees, let's say. Fifth position here also, we have to shift the 3 to here. So 1, 1, 3, 5, 3, 4, 5, 9. So again, this is 25. So total cost is 75. Right. Let me go to the next question. So a sorting technique is called stable if it takes order of log time, it maintains the relative order of occurrence in non-distinct element. It uses divide and conquer paradigm, and it takes order of n space. So what does this thing means? These things I have not discussed. So let's say uh, you have a line in assembly with some students, and let's say you have two students with the same height, a student A and student B, and student A is standing like student A is standing currently at 5th position, and student B is standing at the 10th position. Now a teacher comes and says that I want you to stand as per the height. So the person with the lowest height will stand first, person with the highest height will stand at the end, like that. So in what does stable algorithm means that if I use the algorithm, I can guarantee that A and B they have the same height, and before we started shortening, A was standing before B, so I can guarantee after sorting also it will stand before them. So this is basically used like it is basically used to maintain the relative position. Like if it is like not the not the thing that we are searching on, like let's say height is the thing we are searching based on, then if it is not conflicting, then their relative order will remain the same. So that is what is called the stable sorting. Like it will not mess up the structure if it is not conflicting with the like height in this case. So the answer is B. Then question 10, the average case occurs in the linear search algorithm when so in case of linear search, what we do is that we iterate all the elements, right? So best case is in the beginning, like if we just find it in the first element itself. Worst case is if we go to the end and we find at the end only, or maybe if we even at the end we do not find anything. So that is the worst case. Average case is that let's say we have 10,000 elements, and after going through 5,000 element, I found the like key. So in that case, it is like average case. So it is like the answer is question 10 is item is somewhere in the middle of the array. So that is the answer. Okay, so that is the end of the questions for today. If you have any doubts, please feel free to ask. Otherwise, okay, let me end the session then. Thank you for joined today.